Hello, everybody. My name is Counter Joe. Hello, everybody. My name is Counter Joe, and today I'm going to do Unit 3 mid-unit assignment. Yeah, for number one question. Question: describe what happened to the domain and range of the logarithm function under a vertical reflection. Support your explanation with a graph with a diagram. First of all, I draw a diagram with the gradient f of a is equal to log a and g of a is equal to minus log a. Yeah, particular reflection. We have our parent function f of a is equal to log a and its reflected version g of a is equal to minus log a here. Here, the vertical reflection happens when we multiply the entire function by minus 1. This flip the graph over a is it. This. Notice that for both function the graph stay on the right side of the y-axis. This means the domain remain the same. Okay. The range also remain the same minus infinity to infinity, even though the graph is split upside down, it still go forever up and forever down. The main changes is the y value. It became the exact opposite at every point. Let's move on to question number 2. Describe what happened to the domain and range of the logarithm function under both a horizontal and vertical translation. Support your explanation with the diagram. First of all, I draw a graph with the f of a is equal to log a and g of a is equal to log a minus 2 to minus 2. Yeah. We we apply both horizontal and vertical translation. We are looking at g of a equal to log a minus 2 minus 2. So the the x minus 2 inside the log is a horizontal shift, contrary to what you might think. Minus 2 actually move the graph to the right. Right. Vertical shift the minus 2 at the end of the equation moves the entire graph down by 2 units. This is huge because we shift right, our domain is no longer h greater than 0, but it became h greater than 2. Even though we shift the graph down, the range of the log function is infinite, so the range is still minus negative 2, minus minus negative to minus infinity to infinity. Yeah. We will move to the last question, and the last question number 3. Graph the function f of a is equal to 1 by 2 log x minus 4. Number 3a. Graph the line y equal to x on the same grid. Graph the inverse function f inverse of x by reflecting f of x in the line y equal to x. Number C. Determine the domain, range, and equation of the center of the f inverse of x. D. Determine an equation for f inverse of x. First, we draw the x equal to y line on the graph. Is actually is go from minus infinity to comma minus infinity to infinity comma infinity. Yeah. For number B, graph the inverse function f inverse of a by reflecting the f inverse in the line y equal to x. So we draw the f of a is equal to 1 by 2 log x minus 4 first by putting the 1, 2, 3, 4, 5 as a ace, and y became minus 4, minus 3.8, minus 3.76, minus 3.69, minus 3.65. As a result, all we are putting in x equal to 1, 2, 3, 4, 5. Yeah. Then I flip the from gradient from minus 1 minus, like it's like minus ace or minus, oh, no. No, y ace comma minus y to y minus x comma y. The inverse function and that's what the originate did. Graphically, this is a reflection across the diagonal line. Y equal to 8. Determine the domain, range, and equation of the center of f inverse of 8. 8. Domain of f inverse of 8 is 8 less than 0. It belongs to real number. Range of f inverse of 8 is 0 to infinity. Horizontal asymptote is just y equal to 0. Equal to 0. Yeah. Yeah. For the last question, D, D, we will determine the equation for f inverse of x. First, we swap x and y. X equal to like like this, and it's equal to f into y. Yeah, yeah. Then we isolate the log, add 4 to the both side to get rid of the function, multiply everything by 2. Now convert from log form to exponential form. Since the base is 10, we get y equal to 10 power 2x plus 8. X plus 8. That's all for the unit 3 mid unit assignment. Yes. I hope this helped you master your Unit 3 assignment. If you have question about the log function, drop a comment below. Don't forget to like and subscribe.